Hello guys, welcome to Refer UX. Myself Nimesh. This is the final video of implementation of secure office environment for a small office network. And this video we will show you how to assure or implement secure inter-branch communication using IPSEC VPNs. And also before that I'll do a recap of all first three videos configurations as well. So let's begin. Okay, as I mentioned in the previous video, which is part number 3 video video on ACL, I mentioned that at the end of the video it's all about replicating the same network diagram for other branch officers, because LAN environment is same as the one that we have configured during all these three videos. Hence, I have already replicated same network topology in other branches as well. Here you can see our first branch, we have 10 dot series, and here 20 series, and here 30 series. And also one thing to be noted, everywhere at the distribution layer switch, F0 fast Ethernet 0/1 is connected to the middle one, the third octant value, that is 10. And here also you can see the third octant is allocated just like 10, 20, 30, 40, representing the respective branches. Here also 10, 20, 30, 40. And you can see the 10 is allocated to the distribution switch part F0/1 port. Here also distribution switch F0/1 is allocated to 20.0.10.0/24. So just keep in mind, so that while you are configuring, you won't find any issue, because you can simply follow the flow. So let me quickly configure other two branches, specifically devices and the VLANs and the ACLs quickly, because we have done those things often throughout those three videos. So let me do it quickly. So first I'll go to the 20 series and do it fast possible. All right, great. And here I go there, quickly get that 3, 0, and done. Here I'll go this one, 20.3, 2, 0, and here 20.1, and here again with 20.3 and final this one. Here 30 series, 2, 0, and 1. And here I added 3, final value here should be 40.2 and 40.1, and final file server. Here I add 43. Here and done. Okay, now it has been configured. So just for checking, let me config. All right, it has been configured. Config to, all right, the particular file server is been can be reached. However, the other VLAN cannot be accessed because it is we haven't done the inter VLAN enable the we haven't enabled the inter VLAN communication yet. Cool. And I'll quickly jump to the switch, and then I'll do the relevant configuration. First, the host name as S2. Then I'll quickly show VLAN. You can see none of the VLAN, all the in the default VLAN. So I'll be creating the VLAN quickly. VLAN, the number I will proceed here. As you remember, early case VLAN numbers are from they were ranging from 102, 103, 101, 102, 103, and 104. Here I'll go with the 20 series, so that I'll get VLAN 201. The name of the VLAN is admin. Right. Again, I'll go back and VLAN 2. The name of the VLAN is finance. Cool. Then I'll go back again, creating VLAN 203. The name of the VLAN is what? It is management. And the final one is the VLAN 204. The name of the VLAN is its operation. Cool. Then I again show VLAN. Let me show you the VLAN, and you can see there are 4 VLANs: 201, 202, 203, and 204, and respective names are here. We haven't allocated any ports. Let me allocate the ports quickly. Again, I'll go to ports and interface pass Ethernet 0/1, and immediately I need to give no CDP enable, because otherwise there will be error messages to come that port overlapping. And here then I'll give switch port mod access switch port access VLAN 0. Great. Now we go to the second port interface 0/2. Then again no CDP enable switch port mod access switch port access VLAN. Great. Third one, interface path is 0/3. No CDP enable, and next one is switch port mod access and switch port access VLAN 203. Then final one, interface path Ethernet 0/4. No CDP enable switch port mod access switch port access VLAN 204. Great. We have only one left, that is for the trunk port. So I'll go to the interface path in 0/5 and switch port mod trunk. And you can see that now VLAN, and you can see all ports have been allocated 1, 2, 3, 4, and I have allocated port 5 as well. Let me go back. That is and Again, what I need to do is no CDP enable also here. All right, here I make the more trunk call. Then I'll go back. I will write this and okay. Let me go back and let me go to the router, and I'll go to router and again enable conf hostname R2, then interface fast Ethernet 0/0, no shutdown, okay, exit, interface path in 0/0.1, and encapsulation dot 1q, then the VLAN ID is 201, and IP address 20.0.10.1, exit, interface path Ethernet 0/0.2, encapsulation dot 1q, VLAN ID 202, great, IP address 10.0.20.1, 0, exit, interface fast Ethernet 0/0.3, encapsulation dot 1q 203 is the VLAN ID, IP address 20.0.30.1, 0. And the final one, exit interface fast Ethernet 0/0.4, encapsulation dot 1q 204, IP address 20.0.40.1. All right. I'll now write configuration, show IP interface brief. You can see port 00 is up and 1234.1234 are assigned with the respective gateway IPs. Now let's see whether our configuration works. Again, we go to 20.10. You can see my IP is 20.10.0.10.2, and I ping to 10.3. Of course, my file server is pinging. The other file server, other VLAN, first one should be dropped. From the second one onwards, it is getting connected. Great. Let's see whether I can ping to VLAN number 3 for the management VLAN, management department, and finally, sorry, marketing MGT, and final one is the 40. And you can see it is also getting connected. First one for the ARP resolution, this for 3 and 4. Then we need to assign the ACS, and all right, you can see now the port 5 is no longer here. It is allocated to trunk port. Now I'll go to the router again, and I'll go to the router again. Then I will configuration mode, and I will create access list. It is here we can use the ACL rule as 101, 102, 103, and 104, just like the early case. Let me check the early case. The early case, you can see that show running configuration. You can see that at the end, access list 110. Okay, they are using 110, 120, 130, and 140. And let me go back here in the router 2. So we can go up to 119. Hence, here also we'll go with the same level, 110, 110, and we got deny. What we are going to deny? We are going to deny. We are going to deny any. We are going to deny IP actually from any to destination host of 10.0.10.3. And again, we have to give the same one for the permit case. Permit IP from any to any. Again, we need to move with the second one, that is 120, and deny IP for the host 20. And again, we have to permit 120. Again, the third one, 130. I'm doing this quickly because we have already done this thing, and I'm going to permit fourth ACL 140, and here, and I'm getting okay. Cool. Now I'm going to go to relevant interfaces, pass it 0/0.1, and I'm going to add this thing IP access group 110, and the destination would be out. All right, exit interface path Ethernet 0/0.2 IP access group 120 out. Cool. And interface path 0/0.3 IP access group 130 out. Exit interface path Ethernet 0/0.4 IP access group 140 and out. Great. Write the configuration. Now show running configuration. You can see that each and every sub interface I have allocated the I have added the ACL and the accurate ACLs here. Then let's try for connectivity. Here again, you can see I can easily ping to my own file server from 20.0.10.2. However, if I ping to neighboring file servers, it's giving unreachable message. And if you go to the router, and if you see show access list, you can see that show access list. You can see that from the 120, because we try to ping from admin department, finance department file server. They are from the finance department interface, sub interface. They have blocked for such replies, that is a ping request. So we have clearly configured the second branch as well. Now we'll move to the final branch also. I'll do it for you as well. So here again, we can go as 30.0.10.2 and 255.255.0 and 1. All right. Cool. And the respective file server 3 0 1 done. Now here I'm going the here should be 20.2 and and I can like this, and here again 3 and 0 and 1. Done. Third one, I go here and 30.2, the 0 1, great, and 3 and 0, okay, obviously 1. All right, and here also should be 40.2 and 1. All right, and here what you can do is 3 and 1. All right, cool. And here also we'll see the reachability first in our respective right. We can ping to our own file server, but different file server we cannot ping. Of course, it is unreachable because we haven't configured the ACL yet. So here also I have managed the 10.2.0.1. So what I'm going to do is I'll go to the switch, enable configuration terminal, host name S3, then interface. Okay, we need to create VLAN first. Before that, I'll show VLANs. We have no VLANs created so far. So I'm going to configuration terminal, VLAN. Here we'll create 301, name as a DM admin, VLAN 302. The name of the VLAN is finance, VLAN 303. Name of the VLAN is marketing MGP, and finally VLAN 304. The name of the VLAN is VR. Great. Now we can see the show VLAN. We have 4 VLANs. Now VLAN the ports. Configuration terminal, interface fast Ethernet 0/1, no CDP enable, and switch port mode access, and switch port access VLAN 01. Great. Exit interface fast Ethernet 0/2, no CDP enable, switch port mode access, and the switch port access VLAN 302. Then interface fast Ethernet 0/3, no CDP enable, switch port mode access, and the switch port access VLAN 303. Exit interface fast Ethernet 0/4, no CDP enable, and the switch port mode access, and the switch port access VLAN 304. Great. And the final one, interface fast Ethernet 0/5, no CDP enable, oops, no CDP enable, and switch port mode trunk. Great. show VLAN, we can see that now we have allocated ports here, and right click. Then I'll move on to the router. Then no, and enable configuration terminal. Host name as R3, and the interface fast is 0. No shutdown. Set face fast is 0.1. Encapsulation dot 1q. The VLAN ID is 0.1. Alright, IP address 30.0.10.1. Alright, cool. Then interface fast Ethernet 0/0.2. Encapsulation dot 1q302. IP address 30.0.20.1. Right, interface fast Ethernet 0/0.3, and encapsulation dot 1q303. IP address 30.0.30.1. 0, cool. And finally interface fast is 0/0.4. Encapsulation dot 1q04. IP address 30.0.40.1. Oops, 40.1. Alright, right, show IP interpret. Alright, you can see that port 00 is up, dot 1 to dot 4 sub interfaces respective gateway IPs are there. Now let's see whether we can reach to other locations. Let's say from second VLAN, there is a admin VLAN, finance VLAN. Of course, we have a reachability. It's a proof. Now let's block the using ACS. Again, the router. Go to configuration, access control list. Here 110. Again, deny IP of any to the host. Then again 11 permit, what to permit IP from any to any. Great. Second, I'll create 120, and I host is this. And again 130, 30, 30, and finally 40, 40 done. Now we need to go to interface fast Ethernet 0.1 IP access group of 110 out. Exit. Interface fast 0/0.2 IP access group 120 out. Interface fast Ethernet 0/0.3 IP access group 130 out. Interface fast 0/0.4 IP access group 140 and out. Show running configuration. We can see that We have assigned IP access list also, and let us do same thing as ping thing. Okay, I can ping from my to my own file server, but a different VLAN. I'm saying not reachable. Likewise, if I go to the router and show access list, you can see from the I tried from one first VLAN to second VLAN. It says that 4 matches, that is 4 ping messages came. So we have successfully blocked the uh, accessing FTP, that is file servers from other departments. And of course, I showed you allowing creating FTP access. You can easily create FTP users here and here. So I'm not going to do that here because I'll then now focus on creating because I have already done here. Uh, you can easily create a user here. You can easily select here and go to the services, go to FTP. It is already enabled. Then you can create a user. Let's say test user, and the password is test123. Then you can easily and you can click all the privileges here, then add. So now your particular user, all privileges are here. So likewise you can create that. And now I'll focus on assuring inter-branch connectivity in a secure manner. To do that, I will be connecting them. I'll be connecting them using cables. So what I'm going to do is I'll get this. I'll connect this one to F0/1. Cool. Before doing that, I need to add another module here. The module is I'll go here. I'll go to physical. I'll switch off this. Then I'll add this one, which has which gives me additional um, uh, two interfaces. Then I'll run it. Then let's see whether it is adding, and it is loading, and okay, it's loaded. And show IP brief. We can see that I have an additional another three interfaces, so that I can use for connecting other routers. Same thing can be done here. I'll go here, go to the physical, switch off, add this module, again switch on. And the same thing I'm going to do here, and go to physical, switch off, add the module, again switch on, CLI. And here again I can see that show IP interface brief. Cool, it is there. And again here, enable show IP interface brief. I can see those interfaces. Now let's do the connectivity. I get this, and I get I'll connect to F0 F F11 to F11 here. Okay, then again I'll get F01 to F01 here. Again I'll get F10 here to F10 here. Now we have connected three routers. Now next thing we need to do is enable a routing protocol. After that we will enable the IPsec. But before that, let me write down the networks that I'm going to plan to use here. This is 50.0.50.0/24 network. All right, and here I'm planning to use okay, let me write the exact IP here, 1, and I'm going to plan here. I'm going to use 50.0.50.2 here /24, and here I'm planning to use 100 0.2/24. Here I'm planning to use 50.0.1/. And here I'm using 150.1/24, and here my peer 50.2/. So we have here 2 1, here 1 2, here both are 2. Okay, well, that's okay. Okay, we'll do in a pattern, so that 1 2 again. I'll make this as 1, this as 2, this as 1. That's no rational, but I just do for the equal to 1 2 here, 1 2 here, 1 2. Right, we know the what we need is 1 1 here, 0 1 0 1 here, 1 0 1 0 here. That's the most important. All right, first we will assign we'll assign the IP addresses to the respective interfaces. To that I'm in router 1, and the router 1, the first interface would be F0/1 interface fast Ethernet 1/1. All right, IP address 50.0.50.1. All right, now shut down. Then I'll go to the next interface fast Ethernet 0/1. IP address is 50.0.1 50.2 255.255.255.0, and now shut down. Then I have to go to router EIGRP1 is not 1, the network in R1 is done. Now move on to R2. R2, I'm going to configuration mode, interface fast Ethernet 1/1, IP address 50.0.50.2 0. Now shut down, and the next interface fast Ethernet 1/0. IP address is 50.0.100.1 0. Now shut down. Cool, and the final one is router EIGRP1 network is 0. And write the configuration. Next one is this one. I'll go here and configuration terminal interface fast Ethernet 1/0, IP address 50.0.100.2, and now shut down. Interface fast Ethernet 0/1 0/1. and IP address 50.0.150.1 255.255.255. And we need another one, that is router EIGRP1 and the network. And right, all right, cool. Hopefully now we have enabled the communication between branches now. Let's see whether it is working. And this is for IP config. I'm in the branch 1, let's say. I'm trying to ping my gateway. It is pinging properly. Now I'm trying to ping the 20 range branch first department PC. Uh, First one should be discarded because of the after solution from second one node is working cool. And of course, I cannot access the file server because of the access control. It's cool. Everything is working properly. And I'll access third branch, the PC of the first okay, the second branch, third department. Now let me go to the third branch, first department PC. Okay, it is connecting nicely, and if we try to connect their respective file server, it is getting rejected because of the ACL. All right, guys, by now we have successfully enabled inter-branch communication in this particular lab, and now only matter of fact is enabling IPsec between branches here to here, here to here, here to here. Now let's configuring that as well. That is in that case we can secure the inter-branch communication as well. So I go to router 1 first, then configuration terminal. Then what I'm going to do is crypto ISACAMP enable crypto ISACAMP policy 1. Great. Then encryption AES 28 authentication pre-share. Then the Diffie-Hellman group is 2, and the hashing algorithm should be SHA. Cool. Then what I'm going to do is I'll create the key crypto ISACAMP key. I'll write the key ABC123. I'll use a very simple key, and address is any interface. Okay, now what I'm going to do is I'll create the transform set crypto IPsec transform set. That is, I'm going to encrypt the data tunnel. I'll name this as our set, and then the headers first are ESP AES128 and ESP SHAMAC. So those are the things, encryption methods I'm going to use. And then what I'm going to do is I'll create the access list, IP access list extended. Using here, I'm going to use the extended one as 101 100 here. Here can use a number, so I'm using 100. And then what I'm going to do is I need to permit What I'm going to permit IP. I'm going to permit IP protocol. Then from where to where? Uh, from here, what I'm going to plan is from this network to this network. So this network is 10 dot series to 20 series. So what I'm going to tell the router is 10.0.0.0 network. Anything starting from 10, I'm 10.0. Anything starting from 10.0, I'm going to worry. And the destination would be this, and anything from 20.0 dot I should allow. All right. Oops. All right. Now everything is cleared. Given. Okay. I will permit that. Then exit. I create the access list as well. Then what I'm going to do is I will create the crypto map. Crypto map our map one. I'll create our map one, and the policy is policy one, and IPSEC-VPN. Great. Now it says crypto map will remain disabled until peers are selected. So here I first match the address. ACL address is 100. Then set the peer. My peer in this case is this one. The PIP is 5052. That is 50.0.50. Right. Then set transform set. That is obviously our set. And transform set we have created as our underscore. Oops. But here we have created our underscore. So very important. Our set, right? And that's it. We have done that. Then we can exit and we can go to interface fast Ethernet. The interface that we need to assign is this interface f0/s1/0/1/1. All right, cool. And we can see that if I say that show crypto IPsec oops, I haven't had it yet. Wait, sorry about that. Interface fast Ethernet 1/1. What I have added? Yeah, I haven't added anything. Crypto map our map one. Okay, it is on. You can see that it's on message here. Great. Now, if we go back, right, and show crypto map, you can see that we have only one map. That is one map is assigned to the F01/1. So now we have create part one tunnel, one part of the tunnel one, that is here this end. I'm going to create the same thing in the other end as well. I am going to router 2. Let me I'm going to router 2 here. Now what I'm going to do is I'll do the same thing here. Conf F and crypto ISACamp enable crypto ISACamp policy 1 encryption AES 128 authentication pre-share defilement group 2 and the hashing is sharp. Then crypto ISACamp key A B C 123 and the address is 0000. Then we can create transform set crypto IPsec transform set, which is our set, and ES, then CESP, AES 128 and ESP Charmek. Then we can create IP access list extended, and here again 100 I'm using, and we can permit IP from IN is 20 to this network. Right. It has been created as well. Now we need to create the crypto map. Crypto map, our map 1, policy is 1, IPSEC camp, then match the address 100 and set the peer. The peer is descend, that is 50.1, 50.0.50.1. Then set the transform set, our set. Right, now I go to the configuration terminal, interface fast ethernet, which interface we are going to use, 1/1, here 1/1, and here crypto map, our map 1, that is on. Wait, now you can see that show crypto map, we have one map is enabled. So let's see now whether we'll try this, and let's see whether we can communicate between PC of the two branches. So try to ping 10.2, first packet for I think after solution. From the second packet onwards, great, it is being connected. And if we go here again, show so crypto IPSEC security association, you can see we have two destinations, and you can see IPSEC security association. Of course, we can see local address, remote address, so and so, and the map value and the packets, number of packet decrypted. And of course, if we try again, and can see now number of packet encrypted is increased up to 7, because early there were 3 packets they encrypted, 3 ICMP message, now just 7, which means that our IPsec tunnel is working properly. This is a proof. Now we have an implemented tunnel here. Now we can implement the second tunnel from this branch to this branch. There we can do router 1. So we can use the same policy and same transform set. Only thing, we need to create a separate map with a separate access control list. To do that, what we can do is configuration terminal, IP access list extended, and I can use here I'm using 110, and the permit IP to from this network to this network. Then I can create crypto map, our map 2, our map 2, and the policy is 1 IPSEC. Then I can match the address as 110 and set the remote peer as the peer is here. This is the peer 151. 151. 151. Double check. It's 151. And set the transform set, our set. Sorry, it is our set is there. Then exit and interface fast ethernet. This interface is what? 0/1 interface 0/1 and crypto map our map, and we have added the new map and show crypto map. You can see why that interface is down. Let me show IP interface brief. 0/1 is 152. It is there. It's up. Oops. Let me check whether I have added that in the wrong interface. 0/1. 0/1. Yes. And 0/1. Yes. I can see that 0/1 is being added to the crypto map 2, and these are the relevant details. The PI is 50.1. Cool. Now I will write this thing information. Now I will go back to router 3 and enable there. To enable that, I need to create I think a different separate access IPsec details, crypto ISACAMP, enable crypto ISACAMP policy 1, and encryption AES 128, authentication pre-share, group is 2, hashing is SHA, exit, and then crypto ISACAMP key 123, the address is, then crypto IPsec transform set our set and ESP AES 128 and ESP SHA MAC, then IP access list extended. Here we are using 110. You can use 110 here, and they are used 110 as well, and permit IP, and I'm going to send this network to this network. Great. Then what I'm going to do is crypto. Okay, I'm going to exit. Then crypto map our map 2. Here our map 2, and the policy is 1, and it's a camp match. The address is 110, and set the here as 150 1052 and set the transform set our set and interface fuzzy interface fuzzy Ethernet here what 0/1 0/1 crypto map our map 2 is on. Great. And you can see that show crypto map. See one map is there, that is map 2, and policy 1 and these are the things. Now let's see whether it's working. I will try to ping from this machine to 30, and it is nicely connecting to 30 machine. And let's see in my router show IPSEC show crypto IPSEC secret association. Can see that in the map 2 0/1 they have got decrypted this much of traffic, and inbound and outbound, and okay, and we have map 1 here. It is map 1 details are 7, and the map 4 map 2 here, the map 2 details you will see the, and map 2 you can see this much of packets are being decrypted, and here the map 1 you can see this much of packets, only 7 packets are being detected. Now let's do it again, and if we do it again, and this is map 1 only 7 is still here, but map 2 you can see the amount has been increased. See, so which means that we have a good we have enabled successfully the second tunnel as well. And to check that, you can see here, go here also, you can show crypto IPSEC secret association. You can see only one tunnel is here, no? 01, no other tunnel. There you can see that this much of traffic has been captured. Great. And now we will create the other tunnel, the final tunnel as well. That's the last part. So what I'm going to do is I'll go to the router 2. I'll go there, and we can see in the router 2 show crypto map, and we can see only one map, map 1. We can create map, but we have map 1, and map 1 already created, map 2 created. We will create map 3 here as a second map, and the access list as 120. Yeah, also 120. So what I'm going to do is configuration, and what we are using create IP access list extender 120 permit IP 20.0.0.0 to 30. Then I'll create crypto map our map 3 policies 1 is right match address 120 set peer. Peer is here we have peer 100.20 2 and set the transform set as our set, and interface fast Ethernet, which interface we are enter here 1/0. Wait, crypto map our map 3 done. We have done that, and right show crypto map show crypto map. We can see that we have two maps, map 1 and map 3, both having the same policy, but map 1 the peer is here, this one, map 2 the peer, map 3 the peer is this one. Right. Now we'll go to the other router, that is 3. There, let's say show crypto map. We have only one crypto map, map 2. Now we are going to create map 3. Config and IP access list extended 120 permit IP then we crypto map our map 3 policy is 1 ISACAMP match the address is 120 here is what IP is 100.1 1 set transform set our set interface fast Ethernet. I'm going to add that to 1/0 crypto map our map 3 and show crypto map. You can see we have 3 maps now. Second map, map 3, and their relevant interfaces and the ports. Now let's see whether our third one is also working. I will how our new implementation works with the 3 VPNs we have created among the branches. First, I will get the router 1, and then I will get the router 3, because I'm trying to communicate from branch 10 series to 30 series. Then I'll get those 2. Great. Then what I'm going to do is I will get the show crypto IPSEC security association, and I'm watching here. You can see 49 and 48 values is here. Now again, show crypto IPSEC security association, and here you can see it's again 51, 52 values are here. I'm watching these two. Now what I'm going to do is I will get a random PC from 10 network, and then I will ping from to 30.0. Let's say 40.2, something like that. The first couple of pings will be used for after solution. Okay, second one from second ping onwards it start working, and now let's see whether our tunnel is working. And I will again type this, and all right, Here you can see now the value has been increased to 65 to 62, here also 63 to 65, which means that our tunnel from secure tunnel from branch 10 series to 30 series is properly working. Now I'll show you from branch 10 series to branch 20 series here. To do that, I need to show you router 1 and router 3. So router 2. So I'll remove the router, router 1. I'll remove the router 3 for the time being. I'll get the router 1 here, and alright, cool. I'll get the show crypto IPSEC Security Association. Then I want to watch the interface, this one 50.2. here also I want to check the interface 50.1. here you can see 0 and 0 packets are there, so let me communicate from there as well. So here again I will start communicating to random IP there 30 dot, let's say 2. There also first IP is getting first packet for the ARP solution. I think let's see from second packet nodes what will happen. Second also go. No, right, for the third packet nodes you can see two packets are there. Two ping messages are correctly connected. Now let's see the security association values to check whether our uh, tunnel is properly working. All right, here we need to check. All right, we got all right, cool. We have see 3 and 2 values are here. Two encrypt, two packet decrypts here. It should be also here. Another way around. Cool. It's also here. So you can see the same figures are appearing here, which means that our tunnel from 10 series to 20 series is also working. Now only one tunnel to be checked, that is from 20 series to 30 series. And just for a note, these are all the proofs that you can show to any report that your particular tunnel is working. And also you have to wait a couple of minutes to properly EIGRP to work, and to learn the routing table. And finally I will show you router 3 and router 3 and router 2, so that we have router 2 here, and I will get the router 3 here, and yeah, very cool. And here, okay, I'll get this is I need to check the 100 series. Okay, 97 is the current value, and there is a check here, and the current value for 100 series is yeah, is that 150, and this is 52. Let me check that. First comes, yeah, first one, and it says 103. Cool. Now let's see whether these figures are changing. And to do that, I'll get okay, a random PC here, and I start pinging to 20 series, and it's very nicely connecting on the very first ping. And if you observe the security associations, the respective security association, you can see the 103 has been improved to 114, and here also you can see 90 yeah, yeah, 97 something has also improved to 115. So recently there's a closer, and you can see our tunnel also from 20 series to 30 series also working. So we have successfully completed the configuration of configuration to assure the secure communication or secure interbranch communication as well. In this video, we have shown you the final configuration of implementing a secure inter-branch communication using IPSEC VPNs. With that video, we have completed all 4 videos on implementing a secure office environment for a small office network. If I do a recap, first video we have shown you how to implement a LAN configuration including FTP access. In the second video, I showed you implementation of VLANs and inter-VLAN communication among the branches. In the third video, I have shown you implementation of access control lists in order to avoid or rather restrict other departments accessing each other file servers. And in the final video, that is in this video, I demonstrated how to assure secure inter-branch communication using IPsec VPNs. With these 4 videos, I believe you should be able to configure a secure office environment for a small office network. I believe you have learned something out of all these 4 videos. If you do so, please do like, share and comment. And to know about future implementations of other videos, please do subscribe to us. Till we meet again, have a great time.